Hello. We're going to start the chemical names unit. These videos are intended to help you out and do that. The chapters and sections are for those that we are using in our book. Notice that it is just actually a very small amount within the unit. We tend to spend a little bit more time on it than they would in a normal college class because of the necessary needs for moving on. They usually tend to spend maybe 1-2 lectures, if that at most. So we will be spending it just a little bit more time on it. And these are for your supplemental values. Naming chemical compounds, we are going to go by the rules that the IUPAC has set out. Your book has said, and a lot of other high school books, it is more of a learn the system. Learn the rules, learn the system, and your life will be a lot easier for you. If you know the rules, it makes life easier. Don't try to figure out the why some of this happens. Some of the why these things happen, you'll come to understand as time goes on, or for those of you that are going to go on to bigger and better things, the why will be given to you just a little bit more. But ultimately, learn the rules, follow the rules, and your life will be made that much easier as we continue on. The easiest part of naming is naming the formula units. You've been naming the formula units for quite some time now, or have actually been asked to name the formula units. Those were in our naming quizzes, all 3 of them that we had at the beginning of the year. If you remember, though, there were about 56 elements that were randomly spread throughout. Most, if not all of those elements, will be brought up again when we are going over these naming. And some of them you'll also become very recognizable because we've been using them and talking about them over the last couple units, talking about the atom and the trends within the periodic table. One of the concepts that we've talked about before is the diatomic molecule. And we had 2 different methods for memorizing them. There are 7 of them. So one of the ways to remind us of how to use them was the draw a 7 starting at 7. So we said draw a 7 starting at 7. And element 7 is nitrogen. Now the only element that you miss in that then is the element hydrogen. So you would start at nitrogen, oxygen, fluorine, chlorine, bromine, and iodine, and then you would miss hydrogen. But there are 7 of them, so there comes your other 7. The last one that we said was using the naming system of H, NOF, and down on fluorine, giving you the bromine, chlorine, bromine, and iodine. So you have 2 of them to kind of worry about that. When you see these the rest of this time, you will always see them written this way. It is important to have them and be able to recall them. When I talk about oxygen, when we do chemical reactions, it is oxygen as O2, hydrogen as H2, fluorine and chlorine gases as 2s, and the halogens always as 2s, nitrogen gas 2. So those are things that we will always talk about when we are doing them. The formula units, they're not 2s. They are just the way they are written on the periodic table. The diatomic molecules, there are only 7 of them. That's why they're so important for us to remember. Covalent naming compounds is the other method that we will be using. Some of these are very common compounds. Sometimes you'll even hear them being called binary compounds. Covalent bonds, covalent molecular bonds, covalent binary compounds. They go by a lot of different names. The big thing that we need to remember about these is that they are formed through the combination of nonmetals and or metalloids. It is why we went over talking about the periodic table before we talk about naming, because we need to be able to recognize those nonmetals and or metalloids. If you can't recognize a nonmetal or a metalloid, you're going to have a difficult time. We know the nonmetals are on the right-hand side of the periodic table, and the metalloids are those elements that are touching the metalloid line, that blackened line that starts on boron and kind of stairs its way down all the way down to acetine, polonium at the bottom right-hand corner of the periodic table. Some of these compounds are essential to life, such as water. We wouldn't have it the way it is, life the way it is, if it wasn't for water. And some of these covalent compounds, some of them aren't so good, such as carbon monoxide, and some of these obnoxious nitrogen and sulfur gases that we'll talk about. We'll talk more about some of the bonding that goes into these compounds. Right now, we are going to just focus on the naming. And they're held together by a sharing of electrons. They are not a give and take. They do not form ions. They are sharing of electrons. They have a kind of a mutual understanding that I get the electron just a little bit more than you do, but ultimately they are sharing the electrons. That's going to be important when we talk about in the second and third videos for this unit, where they are forming of ions. Right now we're going to just talk about covalent compounds. They're probably one of the easier compounds to actually talk about. Naming covalent compounds, it is necessary to use prefixes. These prefixes are only to be used with the covalent compounds. Super important. These are only to be used for these covalent compounds. You will be asked to be able to recall these prefixes from memory. Most of them are very easy and things that you have talked about in other classes, such as geometry and even English classes, where you have mono, 1, di, 2, tri, as in triangle, has 3 sides for 3, tetra, 4, penta, a pentagon has 5 sides, hexagon has 6, hepta, 7, octa means 8, nona means 9, and deca is 10. There are prefixes for when there are more than 10, but we're really only going to focus on 10 because if you get more than 10, you're starting to get into some different naming, usually done with organic chemistry, and we're not going to worry about organic chemistry. We'll give a little bit here at the end of the third video that won't actually be in the classroom notes, just at the end of these notes. So it will be important to be able to recall these from memory. Again, it'll be practice, practice, practice. That's why your homework seems a little daunting, a little bit more than normal, but it isn't going to be important when it comes to putting it all together and end up giving us the end result, and it will be a practice, practice, practice. It is the tried and true method for making these stick into your head. To name covalent compounds, I've tried to simplify things as much as I can, so please try not to oversimplify them anymore. Keep them as is. Don't simplify them anymore. It really comes down to 2 steps. Name the element that comes first in the chemical formula, and add the appropriate prefix indicating that number. Now, there is a side note. If the number is 1, if there is just one of that element, we only we just name the element. Then just the name. So it's important that we pay attention to those little things if it is the only just one, because then we just indicate. In some cases, there will be some, I've seen it in some places where mono for the first one is fine. The IUPAC does suggest that you just have to name just the element. Now, if the second element, that's the second step, naming the second element, and that is you have to change the ending. But and if the second element is 1, you do have to indicate. It is important. You have to indicate the prefix, even if just 1, for the second element. But you also have to change the ending to IDE. That will require a lot of practice. Again, that's why we do it enough times. And some of them just kind of start to flow a little bit nicer as you say them, such as oxygen turns to oxide, nitrogen turns to nitride. Ultimately, you're dropping the last 2 to 4 letters and then adding IDE. Why do I say 4? Because phosphorus becomes phosphide, and you actually drop 4 letters in that. Some of these are the reasons why you were not allowed to get by with naming a fluoride or chloride as the correct answer on our naming quizzes that we had last unit. They needed to be done because it indicates either an ion or it's the second element in a compound. So let's start doing some examples. We can see here, first I have 2 nitrogen and I have 4 oxygen. By those subscripts, that tells us what that is and how that goes. And so I start by naming. First step is to name the first element that comes in place from reading from left to right, and that would be nitrogen. But I have 2 of them, so I indicate that by saying and writing dinitrogen. And then the second step is to name the second element. Well, the second element is oxygen. I need to change the ending to IDE, but I still have to put the appropriate prefix, and that would be tetra. Now, this one has a different thing where we would normally say tetra, but, however, because you have the double vowel thing, it's just tetroxide. And it's again, it's the more you come in contact with these, the more you name these, the more your experience in naming. Some of these little oddities of dropping the A and putting the other are there. Now your Mastering Chemistry site will probably force you to name it correctly. If you accidentally leave the A there, for me on the test, if that's one of the things we're naming, I'm not going to go over the board crazy about it. Now the second example, we have, again, 2 elements, but the sulfur atom doesn't have a subscript. So by it not having a subscript, we know that there is at least just one of them there. So all we write is just sulfur. And then we have our second element, which is oxygen. Again, we'll find that oxygen tends to be the very common trait amongst compounds, that oxygen's there. It's the most common element on our planet, and therefore we have sulfur, and more specifically disulfur, because there's 2 of them there. So we say dioxide. I think I misspoke and called it disulfur. So it's dioxide. Now going the reverse, when we say here, it's important to indicate that we don't have any prefix on phosphorus. Therefore, when we write that, we will write just the P for phosphorus. This is where having a periodic table handy would be very helpful, or having all of them memorized. That also tends to be very helpful. When we look at pentachloride, we have to be able to recognize penta is our prefix for 5. Chloride, we're not going to find chloride on our periodic table. However, we will find, sorry about that, just can't write with the highlighter, but we can find chlorine, and it's chloride because I have 5 of them. It's in a compound, and so I have phosphorus pentachloride. Now, disulfur, we have something else going on, is that I have the prefix of di, telling me that I have a total of 2 sulfurs, so I would write S2, and then I have decafluoride, meaning I have deca for 10, and fluoride indicating that I have fluorine, because I'm not going to find fluoride on my periodic table, but I will find fluorine in the fact that I have 10 of them. So we would have S subscript 2, F 10. Capitalization does matter quite a bit when we are doing these. When you're writing out the chemical formula, when you're writing out the chemical name, capitalization is kind of touch and go and dependent upon whether or not it's in part of the sentence. So that was covalent compounds. Now we're going to start talking about ionic bonds. Ionic bonds are by the forming of ions. Now, we talked a little bit last unit about the formation of ions. Actually, we've been talking about it for a couple of them, and that we have 2 different types. That is that we have a cation and an anion. Cations are positive. Again, learning not to use the highlighter. The cations are positive. The anions are negative. And together they form a ionic compound, and that happens between a metal and a non-metal. So you need to be able to indicate which one is which. You need to be able to see which one is the metal and which one is the non-metal. This happens through the valence electrons, and those are the electrons that are in the s and p orbitals that we had been talking about for the last couple of units. And they, again, it's just all this electrostatic force that holds them together, this attraction between the positive and negative that we see within these ions in our compounds. First, though, we will be talking about naming monoatomic ions. And naming monoatomic ions, and it's just getting the names and formulas ready before we start putting them together and making actually compounds. They're just forming of one element, gain or losing of electrons. So we're going to actually name some of the things that we had been talking about over the last one. It is important, again, you've gotten it pretty well, those that I've seen in class, that you never form an ion by the gaining or losing of a proton. A proton defines what the element is. Without that, we have something completely different on our hands. So we're talking about ions here and the gaining or losing of electrons. And so we're going to name just the monoatomic ions. These are just the ion names themselves. So we're going to talk about, again, a cation is a positively charged ion formed by the loss of electrons. Therefore, it has a positive charge. And an anion has gained electrons. Therefore, it will gain a negative charge because it has more negatives. It has more electrons. I use the hypothetical element that we tend to use in my class of BP. We term it palladium, in case you're wondering where element BP on the periodic table. It is fictitious, it does not exist. Hopefully, eventually, sometime, somebody will be honor me with the giving of the name after hopefully their favorite science teacher. One can only hope. So when we write these namings of these monoatomic ions, we write the symbol for the element followed by the charge. Now your periodic table a lot of times will give you the charge that is associated with the element. There are some trends and things that we will talk about, and we will give you some like heads up of, hey, look at this trend, isn't it nice to know? But being as it is, the periodic table that I've supplied you for class has the charges there. So you actually have a lot of information given to you on that chart. To give you some, again, reminders, the main group elements, that's groups 1, 2, and group 13, will form cations under normal circumstances. The charge of that is equal to the last number in the group. That's the trend. If you look on your periodic table, all of the group 1 elements form a positive 1 charge. All of the group 2 elements form a positive 2 charge. The group 13 elements, for the most part, does form a positive 3 charge. There are some things that happen near the bottom as they expand out and beyond, but for the most part, you will see that all of them form a positive 3 charge. Thallium, I think, is the one that forms something else. The main group nonmetals for this class will form anions. That's negatively charged anions almost exclusively. We do that just to make your life a little bit easier as we are going through the learning process. Those positive charges will come back, and we will talk about them again a little bit later. And that's just to give you a little bit better understanding of why those positives are there. But for this unit, all we need to know is to worry about them as having that negative charge. So if you look on those nonmetals, they all have a negative charge, and it's at the top. And there are some trends within that. When we name a cation, a monoatomic cation, all we have to do is really add ion to the end of the name. That's it. That's all we have to do. So when you look at the sodium that has a positive 1 charge, all it is just called the sodium ion. If you have calcium that has lost 2 electrons, it is the calcium ion. Even if calcium lost 1 electron, it is still just a calcium ion. But you might want to indicate that it has lost just 1 electron, although that doesn't happen very often. When we name anions, we do have to change the ending of the element's name to that IDE. You will find that we change the ending of the anions all the time to IDE. And therefore, that's why I said it'll become more comfortable as time goes on, and that's why we do it, to give you a comfort of naming these monoatomic anions before we start putting them together in compounds as we move through. It is important to note and remind us that anions have the IDE ending, and you also then need to add ion to the end and have some space there. So it would be, say, the chloride ion, the fluoride ion, as we are going through this. So let's try it out. As I indicated already before, the Na plus indicates that we are talking about the sodium ion because it has a positive charge. So that's why it's an ion. The fact that we talk about magnesium ion means that I am now going to be worried about the Mg, and I can look on my periodic table and see that it has a positive 2 charge. If you don't have a periodic table, then memorizing the trends becomes so important. But I know that it has a positive 2 charge, or a plus 2 plus charge. There is some reasoning as to why you write the plus first and the number second, or the number first and the plus second, but I'm not going to worry about it for you guys as of right now. I see that Al, what does Al stand for? It stands for aluminum. And it is an ion, so that's what I write, the aluminum ion. Now, for carbon being called the carbon ion, I've kind of set some interesting things up here. You might look on the periodic table and say carbon is a nonmetal, but it's in group 14 and it has 2 positive charges. So which one is it? So for this example, we're going to write both because we have not been indicated as to how to do that yet. So we'll have both of them as the correct answer. Those are the carbon ions. Now, when we look at the next one, I know that this is an anion or a negative because it ends in IDE. Therefore, I know now that it has to be the carbon with a negative 4 charge because it ends in IDE. Being able to see and recognize that. That's why you need to take your time sometimes. You might start to get this and understand it, and then that is when things potentially can go wrong. Oxygen has a negative 2 charge here, and we see that because it has a negative charge, we need to write it out as the oxide ion. Again, the ending of IDE is important to indicate to anybody else that it has a negative 2 charge. On the next example here, we see that we have the nitride. Again, IDE indicating that it is a negative, and therefore, when I write it out, I have a negative 3. We'll notice that some other trends as the Y, it forms a negative 3 more often than not. We'll talk more about that in Unit 3.5. Bromine with a negative charge here. Br is for bromine, and therefore, though because it has a negative charge, we have to call it bromide. And then add ion at the end of it. Now, what about those that don't form just one cation, such as carbon or any of the transition metals in groups 3 through 12? There's not really a hard and fast way for doing that. So we have to figure out some other methodology to do this. Most of them can form more of them. This is a way for scientists to indicate which one we're talking about without having a lot of confusion through any of the translation. And I have 3 different cations of iron. One of them might not even occur, but it doesn't matter. It's the attempt or the method that is being used. If the iron 4 ion, cation, happens, it happens. If it doesn't, you know how to name it. The iron 6 ion is one that is written on your periodic table, but it's the method, it's the system that we have to use. And so sometimes we use that as teachers, is throwing something that may not exist, but is, do you know the system that we're trying to teach you? So when we name transition metal cations, they all form cations. They're metals, the transition metals, although sometimes periodic tables will call them the transition elements. We have to put the element name, we name the element, and then put the charge that is associated with that ion in Roman numerals. So you will need to know your Roman numerals in parentheses with the name of ion at the end. So you will need to know your Roman numerals. Usually all we worry about really is naming them all the way out to 7, because that's the most common one that would be maxed out, although osmium can go 8, so you would need to know 8 as well. Although and again, you will be required to recall these. Some of these will be very easy, some of them you've seen before, and therefore it's not a massively large or difficult thing to do. 1 is represented with just an I. You don't have to put the lines to indicate that. Sometimes you'll just see like 2 is written as 2 capital I's, not always having the brackets at the top. So do be careful about. I put the brackets on top usually when I'm looking at it. 4 is IV. Again, you do not have to put the brackets. I tend to do it at least for the first few of them. 5 is just a V, and then 6 is VI, 7 is VII, and 8 is VIII. Is the method that they use to do them. You will need to, again, be able to recall these from memory as we go through them. But again, it will be a comfort in going through it. But you have to be able to look, and that's one of the questions that a lot of people get wrong, is not being able to recognize the transition metals. You have a periodic table. Please use it. I've told you time and time again that the periodic table is the greatest cheat sheet that a chemistry student can have, because there are a lot of answers on it. Especially for general chemistry and intro to chemistry classes at the collegiate level. It is the greatest cheat sheet if you are aware of the trends and patterns that are there. And it's not considered cheating, because those are trends and patterns that if you know how to do it, it's there. So if you're not sure if an element is a transition metal, a nonmetal, look at your periodic table. This method is actually known as what's called stock or Roman numeral naming. It is promoted by the IUPAC. It is the naming that for naming transition metals. It is much easier than the old system. The old system does still find its way every now and then. I'm not a big fan of it. A lot of those old naming systems will end in IC or OUS, and a lot of times, and it gives us maybe an understanding of why some of the elements have the symbols that they do, such as prick or cuprous, and so it's cupric or cuprous, and that indicates what charge it is when we look at those. Iron is another one where you have ferrous and ferric as well. And tin is another one that happens. And actually it is tin and lead both use this stock Roman naming system, or stock or Roman numeral naming system. Actually, any metal that can form more than one positive ion will use this method. Tin and lead are the common ones. Now, there are some elements that tend to only form, under normal circumstances, only form one positive, such as zinc is an element that tends to only form the positive 2 charge, and silver tends to only form the positive 1 charge. And it is common practice for a lot of reference materials to not use the stock Roman naming for these 2 metals, because it's so rare that they would use anything else, that we don't do that. I prefer that you always use the Roman numerals. You are not or should not be counted incorrect because of that. So let's try out a few. We have Cr with a positive 3. Cr, if we look it up on the periodic table, is for chromium. Ooh, again, not supposed to write in the highlighter. And so we have chromium. It is a transition metal. A lot of you will be looking at how to spell it, so you might as well look for where it's at. It has a 3, so I indicate that with 3, and then add ion to the end. And every now and then I do ones like this to humor myself, where I have vanadium as V, and it is interesting just to point out, again, it's for my own humor, vanadium 5, which is humorous because the symbol for 5 is V, and the symbol for vanadium is V. I do this every now and then to humor myself. It keeps life interesting. This is the method that I like to see silver and zinc written out for. So silver is Ag or Ag with a positive 1. It indicates to us if you have just one of them there, you can use just a plus sign to do that. You can also use a 1, although it's not necessary. But if you have more than 2, such as in the zinc 2 ion, you need to have the zinc 2 plus. Can't put just 2 pluses there. You do need to have it written out that method. Polyatomic ions are, when they're involved, you got to treat them just like any other ion. The naming packet that we have has a more extensive packet of naming, has more exclusive, more names on there for some of these polyatomic ions. Most of the polyatomic ions that are on the back of your periodic table are there. I would suggest you'll learn some of them, again, through practice, but it does pay to know what you're talking about. Get them all together and work from there. So any ionic solids having and involving polyatomic ions, they can have either crystalline or amorphous, be a crystalline or amorphous material. Some of that we'll talk about again in a little bit next week, but know that these are little things that we just kind of add to it as we move on. So these can form that. You will be responsible for learning them. Some of them are very common. Some of them have alternative names, and it is probably the one thing that becomes the hardest part of naming is these darn polyatomic ions. They are very important to chemistry and our everyday life, as we'll talk about when we get into talking about chemical reactions. There's only one of them that's positive, and that is ammonium, not ammonia. It is important that we enunciate these. Ammonia, as we'll find, ammonia is NH3. That's a common name for one of those covalent compounds that we talked about. A lot of covalent compounds have common names, such as water instead of dihydrogen monoxide. But these are not the same. So we do not need to worry or talk about ammonia when we're talking about ammonium. Now, ammonium does come from ammonia. It comes from the hydronium ion, which is a positive hydrogen that's lost in an electron. This was the first video. Again, like I said, you will find more of these polyatomic ions. Again, it is just hear it, see it, look it up. When we name polyatomic ions, we do not change the ending. We have to keep them as is when we go through and name them, such as chlorate and chlorite. We do not change the ending, but those are kind of ways to indicate that that it is a polyatomic ion. The 8s and ites are ways to indicate. and it will determine how many oxygen they have. Determines the eights and ites, the hypos and the perchlorates, and some of those types of things. And those are trends that we'll talk about, or we have talked about in class, but a lot of times ultimately look at your periodic table to help you indicate what are you looking at. And from some of them you will just come to know and learn. But when in doubt, look. Instead of guess, know. And that is how we will look at. Hopefully this first video helped out. The second video will focus on the naming of ionic compounds, and some of the methods that we use to go from the name to the formula and from the formula to the name.